So write this on your card or in the box provided on the worksheet. Xavier, you don't need your Chromebook right now. Maybe later, right? Cody is page number 3. All right, I'm gonna put this away. So our U substitution is going to be our power. Go ahead and circle the power. And let's write off to the side, U is equal to negative x squared. And when I derive, we get du is equal to how many on the right side? Negative 2x. And then what do I need to add on to? Dx. And when I compare, I see an x, I see a dx, but I don't see the negative 2, so I'm going to bring it over by dividing by negative 2. So 1/2 du, or negative 1/2, is x dx. And what can I do with all the coefficients before integrating? Bring it to the front. And while I'm also at it, I'm going to bring the negative 1/2 to the front as well. So then I have e to the u du. So any questions on where something came from where? Just U substitution. Okay, let's go ahead and do our integration then. Let's go ahead and multiply the outside first. So negative 3 over 2. E to the u is always e to the u. And plus times the derivative of that is 1, which we don't need. What do I have to add at the very end? Add the c. And at this point, plug the u back in. So we have negative 3 over 2 e to the power of negative x all squared plus c. And that is our final answer. All right, let's go on to number 2. On number 2, what do we not like about the format of number 2 right now? We have fraction power and we have overall fraction. Let's go ahead and undo the fraction. So we have the integral of e to the power of, just that part alone is 2x to the negative 1. And then when I bring the x squared from the bottom to the top, it is x to the negative 2 dx. So which power do you think our u is going to be? So we have, oh, do I have enough room? I'm going to go up here. U is equal to 2x to the negative 1, which gives us du is negative 2x to the negative 2 dx. Because I need one less in my new power. So let's compare. I see x to the negative 2. I see dx. What do I not see? The negative 2? So let's go ahead and rewrite this. I am going to bring the negative 1/2 to the front. And then I have the integral of e to the power of u du. Good so far? All right, so leave the outside as it is. The integration of e to the u is e to the u times the 1 that we don't need. And what do I need to add at the very end again? Plus c. And let's replace it in terms of x. So I have the following. Okay, I want to do number 6 first and then number 4. So I think I'm going to renumber this. Let's call this one 3. Yes, ma'am?
So what did you do to the x to the negative power of negative 2?
All that was replaced with this right here, which, and then I took out the 1/2 to the front and then replaced it with du right here. Okay? All right, let's go on to the bottom. On the bottom, we have one and only power, so we have to let u equal that. 3 minus x. Now, before I go on further, Do I have the bounds on the integral for this one? Is there a lower and upper number? Yes. So what do I need at the very end? I do not need plus. We're not going to need it. So let's write out du is equal to negative dx. And when I compare, I see dx. I do not see the negative, so bring it to the other side. And then while I'm there, let's go ahead and change our bound to our u. So it says my x is equal to 4 and x is equal to 3. And when I plug those numbers in into my u substitution, what is my new u of the top bound? -1, good. What about the lower bound? 0. And some of you guys might be like, well, 3 is lower than 4, so that makes sense. Why is 0 higher than that? It doesn't matter. As long as your original was already in order, leave it in that order, okay? As in, do not change the top and the bottom. So let's go ahead and plug something in. I want to go ahead and take out this negative outside. So I have a negative of the integral. My lower bound from 3 became 0. From the 4 became -1. And by the u substitution, we have e to the u du. So let's integrate. The negative carries over. Integration of e to the u is e to the u. Again, do I need plus c here? No, I don't. So I have my lower bound and upper bound. And if y'all remember on how to plug this one in, you start by plugging the upper bound to the variable, which in this case I get negative e to the -1. Then plug in the 0 minus negative e to the 0. Now keep in mind, that minus comes from just the formula in itself. That negative is from the original, okay? All right, what do I know about e to the power of 0? That is 1. So if I rewrite this, I'm going to get the following. -1 over e. You could put power of 1 if you want. And we have double negative plus the 1. That is the best answer. If it were to be in a multiple choice setting, it'll be the best answer. If it's free response, can you leave it like this? Yeah. All right. Now let's go to number 4. Oh, number 4. Okay, on number 4, what do you think I might let u equal? Because it's not always the power. It has to be e to the x, because think about it. If I derive e to the x, I get e to the x. So I'm going to satisfy that condition. So let's go ahead and circle that piece. So u is equal to e to the x. Then I get du is equal to e to the x dx. So that satisfies e to the x and dx. Is everyone good with that? Okay, so now let's plug it in. And I'm going to leave the bound open for now since I want to plug it in once I convert everything. We have cosine, u du. So we have when x equals 0 and when x equals -1. And when I plug it in, that's going to give me u is equal to, when I plug it in here, how many is my u then? 1. And when I plug it into the next one, we're going to get u is equal to e to the power of -1. And you can leave it like that or bring it to the bottom. It wouldn't really matter. Because when I write the final answer, I'm going to leave it as e to the -1. So now let's go ahead and integrate. When I integrate cosine, what do I get? Think of snow cone backward. Sine u, and I'm going to leave my bound. Let's plug it in. We get sine of 1 minus sine of e to the -1. And at this point, there's nothing you can do. And here's why. For those of you guys thinking about like 30, 60, 90 triangle, that is not 30, 60, 90 at all. At the degree of 1, we don't know anything about sine unless you're a calculator. Okay? Same idea here. So we can't go on any further. All right, on the back, we got 2 more. And it looks like the copy machine kind of ate part of the instructions. Oops. Xavier, go ahead and read what you can. Number 7.
Find the area of the region bounded by the Gaussian equations.
Y'all good? Good? Okay. So we want to find the area bounded by 1, 2, 3, 4 equations. And I'm going to do a quick approximation and give you a trick behind this. So let's make our X and Y axes. And then let's go ahead and graph everything about it. I'm not going to graph this one yet. That's very ugly. Y equals 0. I think I'm going to use this. So here's y equals 0. X equals 1. And then we have x equals radical 6. That's a little bit greater than 2, right? So I'm just going to go off past the 1 and say x equals radical 6. And it really doesn't matter how you graph the next piece. Just make sure you have some wave. And the area bounded by those 4 equations will create something under the wave, which in the end it's going to be integration. So let's see if y'all remember the trick on the calculator. When you go to math, what number gave us the integration?
8.
Oh, 8 was derivative, math 9. So I'm going to go grab my calculator. If you have your own, get them out. If you have a class set, go grab one. Because if I give you a question like this on a calculator portion, I'm not giving any partial credit. There's really no need to. All right. So we go to math 9, and it'll give you the skeleton model. All right. So if I'm looking at where's my lower bound and upper bound, my lower is 1, upper is radical 6. The function under the curve is the complex equation. And it's okay to leave it as it is because the calculator has that alpha y equals the fraction button. And of course, it's always with dx. So let's go ahead and mimic that. From 1 to radical 6. I hope you're typing with me, so when you get to the test, you're not like, where did you get this button? I don't know. Squared to the 4th dx. Cool. So what was the area under the curve? Negative. I got 1.111. Did you maybe swap the radical 6 and the 1, possibly?
Yep.
Yep. If it goes the other direction, it does positive and negative the other way around. That's okay. Is everyone good on that? So if it's a calculator portion, do not mess up. All right? Okay, let's go on to number 8. And number 8 is simply a review. Milo, let's read the instructions.
Solve the differential equation dy over dx equals 2e to the power of negative x divided by 2 if y equals 1 x equals 0.
Okay? So to solve for y, because in the end I need to plug in when y equals 1 and x equals 0, I need to get rid of the fraction by multiplying by what? Well, what's our, dx, not dy. So we get dy is equal to 2e to the power of negative x over 2 dx. How can I make y by itself now? We integrate. And when I do, I get, let's go ahead and do our u substitution. Circle your power. U is equal to negative half of x, which then will give us du is negative 1/2 dx. So I have a dx, don't have the negative 1/2, so let's further go ahead and multiply by negative 2. So I'm going to go ahead and move 2 things. So y is equal to, let's move the 2 from the original to the outside. What else am I going to move to the outside? Negative 2. Integration of e to the power of u du. So then when I combine the outside, we get negative 4. I should write y is equal to. What is the integration of e to the u? E to the u. What do I need at the very end? Plus c. So then let's plug in our known information. And our known information is not in terms of u, so should we go ahead and convert it? Yep, this guy right here. So we have y is equal to negative 4, e to the power of this guy right here, plus c. This is our general solution. Only if I don't give you any physical value of x equals and y equals, but then I did. So let's plug it in. My y is equal to 1. My x is equal to 0. And we know that's going to give us e to the 0 plus c. What is this going to give us right here? 1. So I have 1 is equal to negative 4 plus c. So c must be how many? 5. I hope that wasn't difficult, right? I know, you guys are like, what? So then I need to plug the 5 in and leave everything as it is. And this is our particular solution, since we know x and y, and specifically we know what the c value is. Particular solution.